Hello, welcome. Today I want to show a little bit about my recent project called WinFinder. It's a kind of replacement to the File Explorer to search for files. So the File Explorer doesn't really work, and even when it kind of does, it's really slow to search for any file. So I decided why not create my own. I know that would be really simple to create. It's not really difficult. And now I want to demonstrate or show the code and explain a little bit how I approached some things, how I did the project. And you can see that it's not really big. It's just 158 lines of code. So it's a really small project, and you can see it running here. So I can click search and find all the files that match the query. So have main.cpp. Okay, so let's first go to the build.bat. This is the batch file that compiles the code. It does a little bit of other things too. So the first line is to disable the echo, because every time you run a command, it basically prints something. So you basically disable that that behavior. So here I just check if the Microsoft compiler is available in this terminal session. If it is not, I call this build, this batch file that is provided by Microsoft Studio. Set up some variables for you to be able to call the compiler. So you can see that it's available, but if I close and try, it is not recognizable command. So it's a real a small annoyance of working with the Microsoft compiler. So next, I basically remove everything from the build folder. Start with a clean slate. Then I obviously create the build folder again. The push D is a push directory, so I enter this folder. So inside this folder, I create a gitignore. You can see here that I create a gitignore with the asterisk. So any file inside the build is automatically ignored by Git, because I'm using this asterisk to basically disable tracking of all the files. So it's a really cool way that I discovered recently that you can do, instead of doing creating a gitignore on your project and specifying the files, the folder that you want to ignore. And you need to also commit that file, so the Git keeps track of this file. So it's one less file to worry about. I think that's really cool. Here is the compiler. So the logo, you can see that when you compile, you have this logo. I think, okay, so this logo, it's to disable this. For whatever reason, they like to have this. And sanitize address is basically a sen. I think in Clang you can also specify this. Basically, it checks for any memory errors. So like if you try to access array out of bounds, the sanitizer will catch. Here this is one for debug information. This is for actually showing what the column of the error is, like a real small arrow where the error is. Activate our errors. This is treat errors as one as actually it's as errors, and this is the maximum error level, I think. This is some flags that I disable. Some of them are for just if you're not using a variable, they complain, and since this flag is enabled, this will be treated as an error and then it won't compile. So it's a little annoying to when you're trying to write code and you're testing several things. So I just disable some of them. And this is the input file. Then I pop from the build folder, and if there is no error on the compiler, then I can run the executable. So now the main.c here is for defining that I'm using Unicode on this project. So it is Windows specific. So the Windows header, the standard I/O, defining the true, false, and a boolean. Some libraries from Windows that is needed for some functions and for the UI. Here I do some type definitions to use a shorter name. So instead of using int, I use signed 32 or S32. So here's the same. I also define a wide character. Since it's Unicode, you can't use ASCII, so you need to use a wide character. Here I define null. Instead of typing like all uppercase, I prefer to write lowercase. Some global variables here that are basically handles to the window, and since it's every component on the UI is a window, that's why it's called Windows. So so you need a handle for each element or component there. That's a handle to the window, so hwinds. Here I include the other files, and this is the main function. I allocate threads. I will show this function in a minute. And I create the window itself. And here is a Windows specific that you need to, every window has a message queue. So you need to iterate that message queue and basically do this to translate and dispatch. And that's basically it. For the threading, I have a file called thread.c, and here I have an array of threads. So it starts at new, and it starts with new, and have a total threads. So I called the allocate threads here, and I grab the number of threads available on my CPU, so I can allocate some memory for the handles of those threads based on the number of threads that my CPU has. And for now, this I think that is. I think the next you should do is, let's look at the create window. So here I create a window, and this is the way that you create one. You need to first create a class and then register that class, and you need to define a window proc that we will see in a moment. Here I get the screen height, width and height. The window width and height are global variables, and I use this hard-coded value. Then I centralize the X and Y position for the window, and then I actually create the window and assign that to the window variable that is here. So let's look at the window proc. That is the biggest function I have. So as I said, every window has a message queue, and a way to process this is you need to have a window proc that you need to assign like you saw at here. You need to assign to the window class. So it has this signature, and here I create some scoped handles to some of the components of the UI. Here static means that it initializes once, so this code will be run only once, since this function, every time it receives a message, this function will run. So a way to create a variable inside the scope of this function without relying on creating outside, it's using static. So I'll also create some IDs to reference when I click. A brush to make the labels background white. For whatever reason, the labels have the default background gray, so I want to be white, so I need this brush. And also I change a variable to hold the font. So here it receives the first message is a create message, and it will run only once this. So I create basically everything here, the entire UI. So the brush, the font, I'm using a modern font. I get the client width to calculate the positions of the several components. Then I create, you see that it's a create window. So here you can see that it's a list box. So that you create a window that is a list, that will be this list here. So it will have the scroll, and you have a way to select each item. So you can also specify some flags and the X, Y position, this width, height, and other stuff. And I set the font to be that custom font here. I create also the label directory, the input. It's called edit. You can also specify the default value there. So if I remove this, it's empty now. So buttons, the input query, button search, always setting the font to that custom font. Here I do a formatting, passing 0, you can see that here at the top I have a string for formatting, so I can pass a number here to then render at in the UI. So the label found and the checkbox and everything that is create, it is here. Now I think that's okay. So destroy, when you click on the X button on the corner of the window, it closes, so that's what it does. This is for painting the labels. And here is for commands. So when the search button is clicked, I reset these two variables. I grab the text from the input. I reset the contents of the list, and then I list files from the directory here. And then I run the threads, and you can see that run threads is a for loop, and I create a thread with the thread proc that we'll see and assign to this. And that's basically it. It starts automatically. When you create, it will run the thread proc. That is a custom function that you can pass. So there's a way to, I think it's this flag that you can specify if it is suspended, so it doesn't start right away. So let's go back to the UI. And then I set a timer for the counter updates for these ones. Since it is, I don't have a really good way to know when all threads have stopped. So I wait a little bit on this timer to actually update the UI when the threads finish. So you can see that I have the timer here. So I set the window text. Basically, I formatting the text with the current value and setting the text. You can see that it's updating the values constantly. And if there is no more work to do, I will show these variables. You basically kill the timer to stop, and then you repaint the window to actually re-render. So it's always based on messages. If I don't call this, it doesn't re-render, so it looks like it's stuck. So that's how the Windows API work. You need to basically, this function is defined here. You need to invalidate React and then update the window to actually issue a refresh on the UI. So here is the clicking the search button. Here is for the updating the values of total files scanned and found. And if it is not clicking on the button but on the checkbox, you basically see if it's checked or not, and then do the opposite and set the value to the opposite. And you can also define here the string match proc. So you can have these two types of functions. So you can see that has enable fuzzy search. You can enable or disable, and we'll change the algorithm for finding the text. And if I go to the string matcher, here's the code for the substring, and I also have the simple fuzzy match, and here I have a global variable to a function pointer. So basically this is a function pointer to this function. So at runtime I can point to a different pointer and change the type of search. So let's go back to the UI. Here I double click for opening the clipboard and copying the clip text, the path to the clip text, and then set the data. Here is when key down, pressing escape to exit. That's basically it, and then you need to call this for any unprocessed messages. You need to call this by returning like you do here. And now let's go to the Finder. That's the main file basically. So it starts with this list files directory. So you can see that when I click, I list files from the directory. So there is current directory. I do formatting here to append this slash asterisk. Then I need to call the Windows API for find first file, and I need to do this do while to search, to go through each file and directory. So first I need to know if it is a directory, and if it is, and it is not, it does not start with a dot. Generally it's a hidden directory like .git, so I don't think it does make much sense to scan those directories. So basically here I add the work, so directory. You can see that add work receives the directory and have an infinite loop. So how this works, you have basically you have this array of tasks that you work to do, and write and read index both need to be volatile because multiple threads will be updating those values. So you need to say to the compiler that it is a volatile variable, and you also need to use atomic functions to actually update consistently these values. So here is a kind of a trick that I learned, that you can use the interlocked compare exchange to update the value if it is equal to other value. So it's a little difficult to understand at first, but I will try. So first, since this is a volatile, you need to basically copy that value before actually using. So for example, if I were to use write index on any other place that it is original index, this wouldn't work, because, for example, if write index was here or here or here, each time that I would read the write index, some thread could go and actually change the value. So I would read a different value each time that I try to read this value. So that's why you need to first basically make a copy of that value. And here I basically do a circular buffer. So when it reaches the max number of tasks, it wraps around, so it goes to 0 again. So work to do is a circular buffer. So I have the next write index, and now the interlocked compare exchange. The value that I want to compare are the write index and the original write index. So basically I'm saying, is write index the same value as the original write index? If it is, then I want to change the write index to the next write index. And it returns the previous write index, so this function returns this. And then I can check if this is equal to the original, then I'm safe to use the index to get the directory from the work to do, and then basically copy the work to do to there. So I'm adding work here. And then I can break. So it breaks from the while true. Now, so here I was listing the files and directories. If it is a directory, I add work to that circular buffer. If it is not a directory, I increment the files scanned. It's also volatile because several threads can operate on that. And so this is doing an atomic increment, and you can also see that update the files found. So here is that function pointer. I call the function that is pointing to, and then I pass the file name or in the query. And if it matches, I basically then I grab the current directory and concatenate with the file name. Here I do a kind of hack. I keep track of the delta time. So to basically want to sleep a little bit, because sending messages to that list window, it is blocking. So if it has a lot of directories, if I'm sending a lot of directories to that window, when you try to scroll, it actually blocks, so you can't scroll, and then it hangs, then you can't move anymore. It basically freezes the program. So this is a way to avoid that. And after sending that, I will repaint. So I issue another message to repaint the window, and that's basically it. And finally, when I was showing here the thread proc when I created the threads, every thread is doing this work. So it's an infinite loop. And this is basically the same trick of before. And here I just check if it is both the write and read index are the same index. This means that it doesn't have any more work to do, because if the write index is different, so it has work, or yeah, it's a write index, because you wrote here, then you update to the next, because the next write index, it is available here. So when there's so we can also wrap around, so you need to actually see if they are both the same, because you can't see if it is a smaller value because of the wraparound. So this is a way to check if it is there's no more work to do. Then it breaks and returns, the thread basically closes. And the same trick again, and this time it calls this function to list directories. So it will list all the directories from that directory, all directories and files, and any new directory that it finds, it puts in that work queue and checks, basically executes this. So you can see that if it is searching here, it will see build folder or directory. It will add to the queue, see if these two of these files matches. And then another thread will look at the work queue, will grab this folder, and then go again searching the files. And if there is another directory, that thread puts another value at the work buffer. And that's basically how the algorithm works. I just want to explain a little bit how the substring works. I prepared a visualization here. For example, it starts both at the same index, and it sees if it is the same character. If it is not, it updates the haystack. So this is the haystack and this is the needle. So you're finding the needle in the haystack. You basically go over. So here it found that the same. Then when it's the same, it goes to the next. Is the same. It finishes. So it is matching a substring. For the fuzzy matching, it doesn't work like this. Okay, so let's try show how the substring works when it doesn't match. So it will reach here, and then when it reads this one, since it's different, it will the needle index will be reset, so it goes back here, since both of these are different. So there is no substring here, and then are different and no match. The fuzzy is very similar, but instead of resetting here on the needle index, when it reaches here, it still continues and see if it reached the end of the substring. So in this case, it finished the substring, and you can see here the lowercase needle points to the null terminator, so it found the substring. Another thing I want to mention is you can see that sending messages to the UI like this, it's really cumbersome to do, and also having to do these kind of hacks to make a fluid rendering system. It gets in a way very easily, so it is not very good for this kind of things. So another way I was thinking of is to use Direct3 3D 11. It's a 3D API, and the basic idea is have a pick message instead of get message. Where's the get message? And you also remove from you pick and also remove from the queue. And if there's no more messages, you render using that the Direct3D API. So you can run, you basically control the rendering loop, which I think is way better than this model of messages that Windows API imposes you. And I think that, so basically would work like any game, rendering at 60 FPS or something. And I think it would be way better and smoother, this experience. But I would also need to implement the inputs and the buttons, all the UI elements. And there is a way to do it like using this approach. I even covered in one of my videos the superior way of doing GUI. So you have this, like in the thumbnail, when the function button returns true, it does the action. So it really simplifies how to write the program. And I think that first 35 minutes of this video is really cool. I think that I showed a really interesting way. I think this explanation was really good compared to all of my other videos. I think that it's the best one so far in terms of explanation and fluidity of the video. And this is actually somewhat of explanation of the EMGUI, Immediate Mode Graphical User Interface. So Casey Muratori that came up with this name, and he explains this in this video. And someone that's implemented already a library called Dear EMGUI, that basically the idea is that API. So for example, you define input text and it renders the input text, and you pass down the buffer that you want to hold the text, and that's basically it. You don't need to do any more things to handle text. the API, the library, will populate the buffer for you. So it's a really cool way compared to a retained mode that you see, for example, on web browsers. And I was thinking about using some library like this, and it's really used in a lot of games. They have a list of games here. For example, a lot of games you can see like the companies that he uses, and there's also a smaller library. I think this is only for C++. This is using C, but this one you need to implement your own renderer. But I want to do without any libraries. You can see that I don't have any, only from the Windows, basically. And I want to be really simple, but maybe in a future updates, I don't know if I want to do an updated version, but if I were serious about this project, I would using something like this or create my own using DirectX 11. And I want to point out another thing that that trick that I used is from Handmade Hero. It's also kind of a course, maybe, by Case Muratori. He's a game programmer, and the series is really good to teach about the basics of programming and also game programming using C, C++, but more of a C++. And it's really good. He explains a lot of different topics of programming related to not just game programming, but some areas related. And there's also, for example, in day 122, he explains a little bit about multi-threading. So he does the same thing that I did, because I basically copied from his code, a circular FIFO work queue. And I think it's really worth to basically watch, I don't know, maybe some episodes of this series and search here on the search bar for any topic that you might be interested. There's a lot of stuff that is really cool, and he explains really well. And there's for example, there's a intro to C, there's a basic warm-up for introduction, and then the actual series, and there's more than 600, almost 700 episodes. But the first few episodes are really good. I highly recommend. And I think it is this paper that he mentions, I'm not sure, that every locking mechanism or multi-threading mechanism, it can be implemented using that compare exchange function. So you can think that that function is the base primitive for any other types of mechanism for multi-threading. For example, mutexes, semaphores, and stuff like that. I didn't read this, but it is something that he mentions on one of the episodes. So I just want to share a little bit about it. And I think that's it. And I covered the entire code, and I think that's enough for this project for now. I don't plan on doing anything more, um, any updates and stuff like that. But it was an interesting project. It was um, a good way to practice multi-threading, to see how I would solve a problem with multi-threading to make it really fast. So the first iteration, as I think I mentioned, that was a simple command line interface, and just being so easy and fast to search for a file instead of relying on the crappy version of the File Explorer. I think it's really cool. And another thing that's also really cool is this, as I mentioned, it's not that amount of code, so you can do a very good job with with little amount of code, and that it is it's basically better software with less code. And of course that it is not complete features, like there's a lot of weird behaviors that I didn't fix, but you can get a long way just by doing the simplest stuff without relying too much on other libraries or anything like that. And the result is pretty cool. I think it's really cool to see it is how fast it is, that it searches like, I don't know, 2 million files or no, or something like. And it solves a real problem, at least for me. So I think that's it for today. So thanks for watching, and I see you next time.